Hi everyone, let's continue now with chapter 6. So we just discussed how to convert between number of moles and the number of atoms that we have. Now we're going to go on to the next component of this, which is to try to relate that to mass. If you remember our original discussion with those nails, what we want to be able to do is weigh them and then using the mass to find out how many nails we actually have. That's how we're going to do it with atoms as well. We're going to need to use something called the molar mass. The molar mass is the mass of 1 mole of that element. So remember that 1 mole means you have 6.02 times 10 to the 23rd of that stuff. And so this is just the mass of that many atoms. Okay. Now before I go further, I want to give you this new term to remember. This number here is what we call Avogadro's number. Make sure you remember it. How do I get the molar mass? Well, simply just by looking it up in the periodic table. So in the periodic table, you see that there's two numbers. One number is the whole number, that's your atomic number, and then the number that's not whole number is your mass number. Now remember that that mass that was given in the periodic table, for example, for boron here it says 10.811, that is what we call the atomic mass, an average mass from all the isotopes of that particular element. So how is that number becoming our molar mass? I'm just going to take carbon here. I'm going to just write 12.01 just for simplicity right now. So the atomic mass of carbon is 12.01. Remember, we use that unit called AMU, or atomic mass unit. Now, what exactly is an AMU? Is just the mass of a proton. And if I look this up, the mass of a proton is 1.67 times 10 to the minus 27 kilogram. A lot of times, instead of measuring this in kilogram, we convert this to grams. So this becomes 1.67 times 10 to the minus 24 grams. That's 1 AMU. So carbon then actually has a mass of 12.01 AMU times 1.67 times 10 to the minus 24 grams per AMU. Now I don't want to multiply this out. I just want to write it like this, and you'll see why in a second. So this is the mass of one carbon atom. Okay. Now remember what we said is that a molar mass is the mass of 1 mole. So that means that if I want a mass of 1 mole of carbon, then that would be 12.01 times 1.67 times 10 to the minus 24 gram. Well, remember that 1 mole has Avogadro's number of atoms. Okay. Now this is what's interesting. If you multiply the mass of a proton and Avogadro's number, it turns out that the answer you get is 1. You can try it yourself in your calculator if you don't believe me. So then you end up getting 12.01 times 1. The atom unit cancel, becomes grams on the top over mole at the bottom. So basically the mass of 1 mole of carbon is 12.01 grams. And of course that number is exactly the same number that we had for the mass of 1 carbon atom. The difference is the units. In one case the unit is AMU, that's for 1 atom, and then when you have 1 mole of the atoms, your unit is grams. When you look at the periodic table now, that same number that has the decimals in it can represent the mass of 1 atom of that element, or it could also represent the mass of 1 mole of atom of that element. So this is what we call the molar mass. What you have now is a conversion factor that says for carbon specifically, there is 12.01 grams of carbon in 1 mole of carbon. Or, just like any conversion factor, I can flip it and say that in 1 mole of carbon, there is 12.01 grams of carbon. You can use this for converting between moles and mass. Let's take a look at this example here. It says, how many grams of sulfur do you have in 2.78 mole of sulfur? So all I need to do is just say I have 2.78 mole of sulfur, and what I want is in the end grams of sulfur. So I'm going to need to multiply this with a conversion factor where mole is at the bottom and grams is at the top. Now grams per mole is the unit of molar mass. So that means all I need to do is go to the periodic table and look up what sulfur is. It says 32.066. I'm going to go back there, put that number in, and then if I plug this into my calculator, I'm going to get 89.1 grams of sulfur. 3 sig fig number, that would be my answer. answer. Okay, so that's how you use your molar mass to help you calculate mass. The next thing is we're going to connect all of these things together, right? So earlier we had learned how to convert from moles to particles. That requires us to use Avogadro's number. Now we just learned how to convert from moles to mass. In this case, we need molar mass. Our goal from the beginning is to figure out how many atoms of something do we have. And all we need to do is take from the mass all the way to the mole. We can take that and convert it to the particle using Avogadro's number. So the example I'm going to use, just the one for aluminum, says how many aluminum atoms are in 3.78 grams of aluminum. So we have 3.78 grams of aluminum, and our goal in the end is to figure out how many aluminum atoms do we have. So the first is we need to take our mass, as you saw earlier. I'm going to take it from grams to moles of aluminum. And then afterwards, once we have it in moles, you can see then we can take it to number of particles by using Avogadro's number. So we're going to do one more conversion here. So the grams cancel. Now the moles need to cancel. And then on here we have aluminum atoms. Okay. And then we need to put in our numbers. Well, grams per mole, this quantity right here is our molar mass. So to find molar mass, you're going to need to go to the periodic table. Aluminum is right here. It's a long string of numbers. So I'm just going to write 26.98 for convenience. Remember, that means 26.98 per 1 mole, right? And then the next thing is I need to do this other conversion, and that's just Avogadro's number. Every 1 mole you have 6.02 times 10 to the 23rd. Okay, I'm going to get 8.43 times 10 to the 22 aluminum atoms. The last thing I want to talk about here is how to do this for compounds. Well, remember, compounds is just a bunch of atoms that are connected by chemical bonds. So if you want the molar mass of a compound, all you need to do is add all the different molar mass of the atoms in there. So the sum of all the molar mass. So for example, if I want the molar mass of carbon monoxide, all I need to do is add the molar mass of carbon plus the molar mass of oxygen. Okay, so once we're talking about compounds, there are different ways to denote the unit of the microscopic object. Generally, you can always call everything particle. Particle is just kind of like calling, saying people, right? You can say there's 10 people in there. That doesn't necessarily specify whether those 10 people are kids or adults, female, male. There's all these other categories you can use. So particle is the generic name for anything that's small. Now, you'll see this term used later on, formula unit. That's specific to a unit of an ionic compound. You learn about ionic compound in nomenclature. So for example, if I want to calculate how many NaCl I have in a certain mass, I would say the answer is given in formula unit of NaCl. I can calculate ions, separate ions, if I want to. I can calculate the sodium ion or the chloride ion in NaCl. I can also calculate molecules. So molecule would be a unit you would use if you're dealing with covalent compound. Okay, so just keep track of all these units that you might see because they refer to different types of object. Okay, so I'm going to show one example here on how to use this conversion. Calculate the number of moles of NO2 in 1.18 gram of NO2. Okay, so they want number of moles. You have 1.18 grams of NO2 and you want moles, so you can take grams to moles, and of course that's just molar mass. Here's the N, here's the O. Now N is about 14, O is about 16, but there's two O's, right? So to calculate that molar mass, you're going to say 14 plus 2 times 16 for the oxygen, the 2 oxygen. And then that ends up looking like this. You add all those guys together, you end up getting 46.0055. This is if you include some more suffix there. And of course that cancels these guys away, so you end up getting 0.0256 mole of NO2. Let me do one more example from the notes. Sugar contains approximately that many sucrose molecules, which has a formula C12H22O11. Question is, what's the mass in milligrams? Okay, so let's start that. So we were told that we have 1.8 times 10 to the 17 of the sucrose, which has this formula. And this is a molecule, right? Because it's a covalent compound. Remember, covalent compounds are made up of nonmetals only. And then the question is, they want you to get your mass in the end. So you got to multiply this with some stuff until at the end you get milligram. Okay, so how do we do that? Well, we follow that same pattern that we've been following for a while now, which is first we're going to convert molecule to mole. And that you just need your Avogadro's number. Now once you do that, you still need to take your mole to your mass, grams and moles. And that goes through the molar mass. So you got to go to the periodic table, find out what the molar mass of carbon, hydrogen, and oxygen, and multiply them by 12, 22, and 11 respectively. So you're going to take 12 times 12 grams per mole. I get this from the periodic table. And then 22 times 1 grams per mole. So hydrogen is 1. I'll just show you real quickly here. Right here, hydrogen 1.00794. And then the last one is oxygen. That's about 16. So plus 11 times 16 grams per mole. When you calculate all that, you should get 342.3 grams per mole. So that's the number I'm going to go up here on the top in my calculation. They're asking me my mass in milligrams. So I need one more conversion, which is just a conversion between grams to milligrams, 1 and 10 to minus 3. So when I plug in all of those numbers here in my calculator, first off, this cancels, and then the mole cancels, and then the gram cancels as well. So my final unit is milligrams. I get 0.102 milligrams.